Good afternoon.
Good afternoon.
Good afternoon.
I'm
Good
fine.
afternoon.
Good afternoon.
I'm fine. I'm fine.
Good afternoon.
Good afternoon.
Previous time,
afternoon.
enough. Okay, thank you. In our previous time, we have summarized, I think, units 1 under physics and the measurement. We have summarized our previous topic, I hope. So try to revise by yourself the question consider with measurement and physical quantities like mass, length, time, and etc. In our today's discussion, we are going to see new topic, what we call motion. Under this one, or in our today discussion, we will see the definition of motion. Everywhere in physics, when you see some topic which is you discuss in physics, you must know it is definition first. So after we have seen definition of motion, what type of motion? There are, for example, at this time, there are 4 type of motion. We will see one by one. Under this one, especially in unit 2, we are going to focus on rectilinear motion. From types of motion, we are going to see rectilinear motion. The consequence, or there is some physical quantities which related with what physical quantities which related with rectilinear motion. So we will focus on that and we will see one by one. So when we talk about motion, motion is simply when we define the term motion. Motion means the change of position with respect to reference frame or reference points. For example, a fixed point, maybe you can take your home or you can take your school and whatever. If you take as reference points, and if you change your position from that reference frame, you are in motion. So when we talk about motion, motion is the change of position with respect to reference frame with time. When you compare with the time, if you change your position, so there is what? There is motion. There is motion. So motion is the change of position. The change of position. Let us see what is motion means. Definition of motion. In unit 2, as I have said now, we are going to see definition of motion. Definition of motion is, when we summarize, motion is a continuous change in position of an object relative to the position of a fixed object. Relatively. When we talk about motion, we are talking relatively with a fixed object called reference frame. Reference frame. For example, when you compare in one reference frame, you are in motion. And by another reference frame, you are maybe you are at rest. Let us see, for example, if you sit in the car, relative to if you sit in the car and come to school, relative to your home, you are in motion. Relative to the chair of the car, you are at rest. Therefore, when we talk about motion, you must consider from what type of reference frame. From what type of reference frame. So motion is a continuous change of position of an object relative to the position of a fixed object called reference frame. For example, reference frame can be your home, your school, a tree, mountain, anything at rest can be used as what? As reference frame. Reference frame. Therefore, motion of an object or motion is a continuous change in position of an object relative to the position of a fixed object called reference frame. Reference frame means a fixed object. A fixed object. Maybe it can be home, tree, mountain, stone, and whatever which is a fixed object, you can take as reference frame. So from today again, you know what is the definition of motion, what's the definition of at rest again. For example, if an object is not moving, we say that it is at rest. If an object is not moving, we say it is at rest. If there is no change of position, if there is no change of continuous position, we can say that object is at rest. At rest. That means that object is not moving. That object is not moving. So when we talk about this one, you must know what is motion means, what is at rest mean, and what is reference frames are, and what is the example of reference frame. So your home, a tree, a mountain, and anything at rest can be used as what? The fixed point. The fixed point means again reference frame, which all distance are measured. For example, when you measure a distance, you must take one reference frame or one fixed point. This fixed point is called reference frame or reference point. To compare, to refer your position or your motion, you must take one reference frame. Therefore, reference frame means, or reference point means, the fixed point from which all distance are measured are what we call reference frame. So in this point, you must know what is motion or the definition of motion, what is at rest, and what's the definition and the example of reference frame. What is the definition and the example of reference frame? You must know. You must know. So if you know these points, good. The other one is based on the path followed. Based on the path followed, emotion can be classified into 4 types. What path we followed? When we move from one place to place, what path we followed? So depending on this one, motion can be classified or categorized into 4 types. Into 4 types. The first one is rectilinear motion or motion along a straight line, vibratory motion, rotary motion, and vibratory motion, rotary motion, and rectilinear motion. So we will see this one one by one. What is example of, for example, what is rectilinear motion means? What is the example of rectilinear motion? And curvilinear motion means, vibratory motion, and rotary motion means. We will see one by one. We will see one by one. So when we talk about rectilinear motion is a type of motion which occurred along a straight line. Along a straight line. The first one is, as I have said now, this what rectilinear motion. Rectilinear motion. For example, if you run on a straight line, you are your motion is a type of rectilinear motion. A type of rectilinear motion. A type of rectilinear motion. Rectilinear motion is a motion of a body along a straight line. All motion which is occur on along a straight line are rectilinear motion. All motion which occur along a straight line are what type of motion? Rectilinear motion. Example, a falling body from a certain height, motion of a car along a straight line. Along a straight line. So motion of a body along a straight line is what type of motion? Rectilinear motion. Rectilinear motion. So rectilinear motion is a motion. Simply, rectilinear motion is a motion of a body along a straight line or along a straight road. So, for example, when you draw from a certain height, a ball or anything, that type of motion is rectilinear motion. Rectilinear motion. Motion of a car along a straight line. For example, you can take motion of a plane in the sky. Motion of the plane is in the sky is a type of what? A type of what? A type of rectilinear motion, okay? A type of rectilinear motion. Have you understand? Have you understand what is rectilinear motion means?
Yes.
Yes.
Okay.
Yes.
So, in above our discussion, you must know what is motion means again. What is at rest when we talk a body is at rest. Why we talk or why we say that body is at rest, you must know what is reference from. And now we are, you must know the type of, from the type of motion, what is rectilinear motion and which it is example. To say one motion is rectilinear motion, it must be occur on a straight line, on a straight line or along a straight line, along a straight line. The second one is curvilinear motion. Curvilinear motion. Curvilinear motion is a motion of a body along curved paths. You know, for example, curved paths. If the motion is occur on curved paths, you can say that motion is what type of motion? It is a curvilinear motion. A curvilinear motion. For example, motion of a car around circular paths. Circular paths. For example, if you take motion along a circular path, is a curvilinear motion. If you take the motion of a car along, for example, a mountain or maybe a type of curved river, if you take such a type of motion, that motion is curvilinear motion. Curvilinear motion. Motion of the ball thrown horizontally from certain heights. For example, if you throw a ball from certain heights, this seems like projectile motion. What you will see this one in higher class. If you throw a ball, such a type of height or from a certain height, this ball make a curvilinear motion. A curvilinear motion. So from a certain height, if you throw a ball, it moves. What type of motion? Curvilinear motion. By the motion of curvilinear motion. Have you seen? And the other one, the motion of a moon around the earth. For example, I think you know this one. Moon is a satellite of the earth. A satellite of the earth. The moon rotates or rotates around the earth, or move. The motion of the moon around the earth is one type of curvilinear motion. Because of what? Because of the shape of the earth. If you take the shape of the earth, somewhat circular one, circular one. The shape of the earth, if you take the it seems like egg, the shape of the egg. When the moon rotates around the earth, it make the motion of curvilinear motion. Curvilinear motion. Therefore, curvilinear motion is a special case of curvilinear motion in which the body moves along circular paths. The motion of a body which occurs in circular paths is what we call curvilinear motion. Curvilinear motion. Okay? Curvilinear motion. So there is some difference between them. If you take the first one, it is along a straight line. If you take the second one, it is along a curved path. A curved path. All of motion which is occur on the curved path are called curvilinear motion. Okay, curvilinear motion. Curvilinear motion. The third one is rotary motion. Try to identify or try to understand what's the difference between curvilinear motion and the rotary motion. Curvilinear and the rotary motion. When we talk about rotary motion, it is the motion of a body about an axis. There is no change of position from an axis. For example, if you take Earth can make two motion. The motion as the sun and the motion on what? On its axis. So The motion of an Earth on its axis is one type of rotary motion, but the motion of the Earth around the Sun is a type of curvilinear motion. Curvilinear motion. Therefore, rotary motion is about an axis. The motion of a body about an axis. For example, you can take this one, the motion of a second or a minute arm of a wrist watch. If you take the second arm on the wristwatch, it rotates about an axis. There is no, from the axis, there is no change of position from the axis. Therefore, it is about an axis. Weight of the motion of a wheel of the car. If you take the motion of the wheel of car, it rotates again on what? On about an axis. Therefore, the motion of about an axis is what we call rotary motion. Rotary motion is the motion of a body about an axis. Therefore, it is examples of rotary motion. The motion of second or minute arm of a watch, or you can say the hour tube, the arm of hour of a wristwatch is again a type of what? A type of rotary motion. Rotary motion. So under this one, you must know the definition of type of motion, and it is example. The type of motion, and it is example. So the fourth one is vibratory motion. Vibratory motion here, a body is to and fro. You know this one, to and fro. Vibratory motion is to and fro, and back and forth, or down and up. For example, back and forth, down and up are a type of motion, what we call vibratory motion. This motion does not have constant velocity. Vibratory motion, and they are what? Periodic motion. Rotary and vibratory motion are periodic motion. We will see this one. Later. So when we see the examples of vibratory motion of pendulum. You know pendulum. Do you know pendulum? What's pendulum mean?
No.
A type of watch. Which counts by, for example, if you take pendulum, you can see by this pop. Sorry for my figure. Come to here, and again it come back, and it makes such kind of motion. And I'm using back and forth. Such type of motion is what we call vibratory motion. A suspended, or the motion of objects suspended. For example, on a spring, if you suspend an object, it makes the motion of vibratory motion. For example, if you take the motion of a suspended, especially on a spring, if you take such a type of motion, it's what it makes up and down. Such type of motion is what we call vibratory motion. The other one, water wave. What is water wave, by the way? What is water wave? Do you know? Do you know lake?
Yes.
You know a water parts, what we call lake. If you throw a stone in the middle of the lake, what you will see? If you throw a stone in the middle of water, such type of lake, what you will see from the surface of that water? What you will see? There is what? There is no change. There is motion. If you throw in the middle of an ocean or a type of water parts, what we call lake, from the middle up to the edge of the lake, there is motion. What type of motion? Water wave. What do we call water wave? Okay. So water wave is a type of what? A type of motion or a type of vibratory motion. Again, if you hit a rope, if you hit a rope which is straight, energy in the rope or the motion, there is motion in the rope. This type of motion again is a vibratory motion, a vibratory motion. So vibratory motions are a motion of a body to and fro, to and fro, you know, to and fro, and the back and the forth, and the, or up and down. Such a type of motion is what we call vibratory motion. Vibratory motion. So you can check if you see the pendulum motion. The pendulum motion, you can see such a type of motion is what type of motion? Vibratory motion. Okay, vibratory motion. Okay, both rotary motion and the vibratory motion are periodic motions. Both vibratory motion and the rotary motions are periodic motions. Periodic motion means periodic, you know, periodic, in a certain time. In a certain time. That means periodic motion can have constant or non-constant velocity and they repeat by themselves. If you take the motion of pendulum, it's repeat by itself. It's repeat by itself. And for example, if you see the motion of the wheel of the car, it repeats. It repeats. So periodic motion, for example, if you take the pendulum, it do have constant velocity. For example, if you take the motion of the cars, the wheel of the car, maybe it do have constant or non-constant velocity, but it repeats by itself. Such a type of motion is what we call periodic motion. Therefore, rotary and vibratory motions are periodic motion. Periodic. That means it repeats by itself or by themselves. They repeat. They repeat. You can take the motion of the wheel. Look, when you ride or some person ride the car, you can check the motion of the wheel of the car. And if you get the pendulum watch, you can check again. You can check again. So they repeat by themselves. So we can categorize generally motion in 4 categories, or we can classify it into 4. We can classify it into 4. So the first one is what? What type of motion? The first one is what type of motion? Rectilinear motion. What's rectilinear motion mean? What's rectilinear motion mean?
Motion along a street.
That goes in a straight line. Motion that goes.
Motion that goes on a street.
The second one is curvilinear motion along curved paths. Along curved paths. And the third one is rotary. The fourth one is vibratory motion. Therefore, you must know their definition with their example. You must know the types of motion of its definition and with its example. To say one motion is periodic, vibratory, rotary, curvilinear, and etc., you must consider if it fulfill its definition. If it fulfill its definition, you can categorize one motion under the given types. Okay, under the given types of motion. Have you understand what we have still now?
Mister,
Yes.
I have a question.
Yes.
In vibratory motion, the motion, this motion does not have constant velocity. What does that mean?
The motion does not constant velocity. Maybe this one is, for example, both rotary and vibrating motions are periodic motion. They do have constant motion, constant velocity or non-constant velocity. We will see about constant velocity. For example, when we talk about constant velocity, in a given time, it covers equal displacement. For example, look, we will see this one in next period. What type of motion is constant velocity, and what type of motion we can say constant or uniformly motion and uniformly accelerated motion. We will see this one in future. But for example, in 1 second, if one object or a moving object covers 3 meters, and if that motion is constant in 2 meters, how many should it be cover the distance or displacement? It should be covered 6 meters. So in 1 meter, 3, in 2 seconds, 6, in 3 seconds, 9. This type of motion is constant speed or constant velocity, we can say. So such type of motion is constant velocity, but vibrating motion can be periodic motion. Okay, we will see what type of motion is constant, have constant velocity and have constant acceleration. We will see this one in future. Okay, we will see this one in future. Have you understand what I wanted to say? Yes.
Yes.
Okay.
Yes.
Let us focus on, from the given types of motion, let us focus on motion along a straight line. Motion along a straight line. We will see from the type of 4 types of motion given for us. Let us see motion along a straight line. Motion along a straight line. Motion along a straight line is, or path, is what we call rectilinear motion. The other name of motion along a straight line is what? Rectilinear motion. Rectilinear motion. Therefore, in a rectilinear motion, a body moves over a certain distance along on a straight line, and it takes a certain time. Look, when an object moves over a certain distance along a straight line and it takes time, there are another effects of, for example, motion along a straight line, like distance, displacement, velocity, and speed. So under motion along a straight line, we are going to see about distance, displacement, speed, and the velocity. So what is the difference between distance and the displacement? We will see. What is the definition of distance? What is the SI unit of distance? And the EDC, we will see, okay, under these points. For example, in a rectilinear motion, a body moves over a certain distance along a straight line, and it takes a certain time. When this occurs, there is distance covered. Or there will be a distance which can be covered. So under this one, what is distance mean? We will see. What does distance mean? We will see. For example, distance is the physical quantity which describes the length between 2 points. If you remember in our previous time, what is length mean? Do you remember? What is length?
Yes, they cover the
Length
distance
is-
between 2 points.
Look, compare with this one. Compare with this definition. Then distance is the physical quantity which describes the length between 2 points. So distance, and then, for example, distance is a type of length, height is a type of length, base is a type of length, width is a type of length. They are lengths, but they are lengths. So distance, the definition of distance is the physical quantity which describes the length between 2 points. For example, if you take 2 points, points P and the Q, the length between this one is what you can say distance. At what direction, we don't know. At what direction, we don't know. So the length between 2 points is distance. The length between 2 points is distance. So when we talk about distance, again, it is the total path length traveled. We don't care about it is definition, okay? We don't care about it is sorry, it is direction. For example, if one body follows such type of journey or such type of trip, this is a distance. So the total path travel or the total path length traveled by a body is what we call distance. This one can be, we will see, this one can be maybe displacement, again this one, again distance. So it depends on the path followed. For example, if one person go or moves to a north 200 meter and then again come back to south 400 meter, the total path covered by a body is around 600 meter. 600 meter. Therefore, it depends on the path followed. Okay, it depends on the path followed. That means it is the total path length traveled. It is the total path length traveled. And the symbol of distance is S. Instead of you write distance, distance means S. The symbolized or it represented by S. And it is a scalar physical quantity. There is, when you describe distance, no need of mention direction because it is a scalar physical quantity. So it is expressed or described by what only? Described by what only? Described by what? By magnitude only. Scalar means magnitude only. Described by magnitude only, okay? Distance is scalar physical quantity. That means distance is described by only magnitude. For example, distance is equal to 10 meter. At what direction? We don't know. We don't know. There is no direction. So distance is a scalar physical quantity. Scalar physical quantity. The SI unit of distance is meter. Like what? Like length. The SI unit of length is what? Meter. So the distance, the SI unit of distance is the SI unit of, you know what is SI unit mean? SI
Yes.
unit, you know, international unit system. So the SI unit of length is what? Meter. The SI unit of length is distance is meter, as similar to the SI unit of length. Similar to the SI unit of length. So under this one again, what you must know, what is the definition of length and the symbol, whether it is as it is scalar physical quantity, it is SI unit. If you know this one, again, it is very good. It is very good. Have you understand what is distance mean?
Mr. I have question.
Why distance, displacement, velocity, and speed are?
Sir, I have a question. Mister,
Leah is the host now.
ማን ያውቃል?
እንደዚህ አስር የሚሆነው
እኔ እንጃ ዋይፋይ ተቋርጦ ይሆናል።
Why am I the host?
የሚቆረጠው
ሆስት ላደርግ ነው እንግዲህ።
Why am I the host? Oh my god.
because
ሚስተር ገባ መሰለኝ።
ኦኬ ኮኔክሽኑ መጥቷል። አሁን መጥቷል።
አዎ
ايش ايش
I have a question, Mr.
okay okay ይታያችኋል አንተ
አዎ ይታያል ይታያል
ይታያል
በደንብ ይታያል
yes
ይታያል
የስ
ሚስተር።
ይታያል ሚስተር በደንብ ይታያል
እሺ
Can I ask you a question, Mr.?
okay okay connection on so under motion along straight line the okay distance displacement speed velocity are what they are the effect of rectilinear motion okay or the effect of motion along straight line so let us see again what is displacement mean what is displacement have you seen distance displacement displacement is the change of position in a certain direction so look distance is the change of position without direction the change of position without direction but displacement is the change of position yes with a certain direction for example have you seen displacement can be symbolized by s with an arrow on its head so displacement is equal to 10 meter at what direction maybe west or east or north or up or down so if change of position is described with a direction we call it is displacement we call displacement therefore displacement is equal to distance plus direction distance plus direction if a distance have a direction we call that physical quantities displacement so displacement is a change of position in a certain direction so it is the shortest path or the shortest path in a straight line with a certain direction for example we will see this one and then a displacement is described by both magnitude and the direction so if distance expressed with direction it become displacement and its symbol is s with arrow on the head look if you put an arrow on the head of the symbol of distance it become displacement therefore this arrow shows what this arrow shows this arrow shows vector quantity this arrow shows vector as it become vector quantity therefore displacement is vector physical quantity this SI unit is the same with length again with what with the distance the SI unit of displacement is what the SI unit of displacement is meter the SI unit of length is meter the SI unit of distance is meter too for example if you take this point and B point if you take or if there is such a type of motion this one is maybe pass one here is again another pass again it can be another pass it can be again so on which pass shows for example which pass shows displacement number 1 number 2 number 3 or number 4 which pass shows displacement
Number
pass
one.
Yeah, pass 1 because it do have a certain direction. If you take pass 2, once it go to what or it move to north, again come back to south, again north, south, west, and east. There is no direction. Therefore, except number one, all of them are distance. All of them are distance. Therefore, this is distance. Number one is displacement. Number three is distance. Number four is distance. Except number one, all of the paths which is exist on this borders, what we call distance. Therefore, in our today discussion, we have seen about the definition of motion, type of motion, and the type of motion. We have seen the definition of distance and the displacement. The difference between them is distance is scalar physical quantity, whereas displacement is vector physical quantity. So we have seen these points in our today discussion. If you do have any question, welcome.
Yes, Mr.
If no,
I have a question.
our time is up. Yes,
Sir, he has a question.
okay, wait me. Yes, the first one.
Hi.
Students.
What
type of
is the
question?
what is the difference between
Yes?
Use your
rotary? What is
PlayStation
the
in a brawling.
what is the difference?
User.
What is the difference between rotary and
Wait. What?
what is the
Between
difference
what and what?
rotary motion and the curvilinear motion?
Read the same textbook.
Curvilinear motion and the rotary motion. Have you seen?
Yes.
Curvilinear motion
Yes,
is
do you think of
motion
the
along curved path, whereas rotary motion is motion
when is it?
along on what? About an
sorry.
axis. And on about an axis. Okay.
Okay.
Mister,
Yes. Yes.
I have a question.
Okay, continue.
Physics ያስፈልጋል
Yes.
ለፊዚክስ ስንት ደብተር ነው የሚያስፈልገን?
እሱ መደበኛ ክላስ ሲጀመር ብናወራ አይሻልም?
አይ አሁን ድና እንትን
ለጊዜው አልታወቅም።
ሚስተር አሁን እናውቃው።
አሁን እንድናዘጋጅ ነው።
እሱ በቢሮ በኩል ጠይቁና ያለውን አዘጋጁ። እሺ
በቢሮ በኩል እንትን ይላል።
Okay, I think enough in our today discussion. Let us summarize. Goodbye.